All right, I have a lot of inflammatory stuff to say and only half an hour, I guess, to do it. So I'm going to kick off and try and stick to time here. We'll do questions at the end. I'll try and carve out some time for that. I do want to begin by just thanking you all. First of all, how many people here are from Boston? Like actually like live in and or around Boston? One, good. That opens up a lot more comedic territory for me. I'm from New York. So, okay, good to be here or not. Let's dive into it. So this discussion, this talk is actually, it's completely fortuitous and serendipitous that I happen to be speaking after David. David and I see very closely eye to eye. You can think of us a little bit in this context like a late night schedule, like, you know, it stays a little bit more mainstream, and then like by the time Craig Ferguson comes on, all the gloves are off. So you can think of me a little bit like that because I wasn't an original Kubernetes core team member, so I don't know. I don't have to say I love it. Okay, Edge AI's scariest question, where's my data backbone? So the first thing I want to talk about is just a definition of Edge so that we can level set. By way of introduction, my name is Michael Tanenbaum. I'm the co-founder and CEO of Mycelial. Before this, I was a principal solutions engineer and the head of the field AI/ML practice at a company called Mesosphere, which they then changed their name to D2IQ. So I don't know if there's anyone here from the early days of distributed computing with Apache Mesos, rock on, which actually has so many architectural similarities to Backyao, and we are Backyao users ourselves and collaborators. So so much to love there. So let me just take a second and provide a description of what the edge is, at least as we think of it as Mycelial and the nature of the work that we do. And for us, it's anything outside the data center. So I like to joke with all of our clients, like all of our customers, you know when you're in a data center. It doesn't look like anywhere else. It's a contrived place that was created due to certain limitations in computing that may or may not still be valid today, right? And may in fact not even fulfill the needs of what we need today. So the data center is a fait accompli, but it may not be here forever. So what are the reasons why? Where is it failing? By anything outside the data center, I mean mobile phone browser tab, right? Especially as we're talking about WebAssembly. This talk will touch on some WebAssembly. Embedded devices now with Rust, especially with the Rust WebAssembly sort of development toolchain being like increasingly the default, et cetera, et cetera. That is what we mean when we say edge. If you have a rack of servers sitting in a POP somewhere, like a Cloudflare or a Fastly or something like that, that to us is a data center. That's a mini data center that you recreated in a closet. That's if it's a bunch of servers in a rack slung together with like Cat5 cable, that's not the edge as far as we're concerned. So the next question is for those who are, you know, perhaps in a situation where, okay, this all looks very cool, but like why do I care about AI at edge? What is the relevance for me? And the reason I'm mentioning this is because if you're anything like me, you interact with clients all the time who may or may not have familiarity with sort of these issues, and I find that these are helpful metaphors and abstractions to use to help folks who may not be so familiar with the space get acquainted. I hope they're useful for you, even if, of course, you know what AI at the edge is all about. But the way I like to describe it to our customers is if you are interacting with a computing device in 2023 and you are not typing on it or tapping on it, you're using AI/ML. Right? If you're speaking to a computer, if a computer is watching you do something and helping you out in some regard, if a computer is going through your intestinal tract with a camera, if your smart thermostat is adjusting itself, these are all computing devices, and some of them interact with us in more human ways, and some of us interact with us in less human ways, right? Typing and tapping is not a way that we interact with anything other than computers, right? When we speak to each other, we use a language, a human language of some kind. And so when we have this contrast between where we live and where computation happens today, we see that they are very different in almost every single aspect you could possibly imagine. So conceptually, having worked in attempting to squeeze AI onto everything from toilet paper manufacturing machines to US Navy submarines, to F-16s at the Air Force, over the past few years. There's a lot of benefit to be had from deploying AI at the edge, some of which David spoke about. In particular, you cannot centralize all of the data. There's a fellow by the name of Kit Plummer who runs a big government research lab at Georgia Tech, GTRI, Georgia Tech Research Institute, who once had a fantastic LinkedIn post that I wish I had screenshotted, because he said the DoD has not figured out that they cannot flush the toilet with all the data, which is to say the bandwidth, the pipes simply don't exist. So when we look at the broader challenge of edge AI, what I've observed is that there are generally two sides, what I call the two sides of the edge AI ML coin. On the one hand, you have the sort of compute, you can think about it for this audience like computational infrastructure. For a less sophisticated audience, I would say this is the thing that serves your model, right? This is the program, like a VCR that takes a cassette tape. The cassette tape is the model, you can swap it in and out, but that infrastructure is there so that it can run your model, you can run inference off it. And then there's everything else, right? So in the context of David's talk that you just saw, we're the arrows, okay? Every time you saw a box, that's David. Every time you see an arrow, that's us. So in solving this problem, it's not just a question of standing up like a Jetson Nano or whatever and like plugging a model on top of it, doing computer vision. That's simply not enough. Even if you solve the problem of code distribution, logging, monitoring, model tracking, drift detection, threat detection for your model. By the way, there's a talk that David gave several years ago at KubeCon about threats and attack vectors for AI/ML, very much worth watching in particular, because these are all critical things, but they do nothing for the movement and orchestration of data intelligently based on all that work you did to set up the model. So these are purely data problems. First inflammatory thing I'm going to say, microservices are a lie. Right, like it's great. Now you have a bunch of other stuff that's not working. This is what most folks have running in their system. Some gobbledygook that looks like this. So if we take a step back and just isolate for a second one thin line of this pattern from getting to A to B to C, we generally speaking come up against something that looks like this. Right, so in David's talk that you saw before, there were assets on one side, and then there was a data center on the other side. Then there was one straight arrow. Everyone here understands that that arrow is in fact many boxes and many arrows. What I like to joke with my customers is that the one element from every single architectural diagram that I've ever seen in my entire career, the one element that's always missing, price tags. Right? Every box and every arrow is a price tag, either in terms of like human care and feeding, or in risk, or in AWS cost to deploy your brokers in different availability zones, and also charge you for that, right? So these are sacrifices that we made in a world in which the only way to be able to handle what we used to joke about at Mesosphere back in the day, Justin Bieber tweeting. Right? The only way to handle that was to develop cloud orchestration systems like Mesos and later Kubernetes, and so on. That being said, there are so many of these different tools that have to be on all the time. Your API gateway has to be on. Your Kafka has to have 3 brokers, right? Your $15,000 a year for a prod Kafka cluster, no matter what, right? I don't care what data center you're working in. And then you have, of course, your cache. You have like different other downstream consumers, like a database and so on. Then you have to maintain an API set on either side of these as well. Generally, that's fairly custom. So what I say to a lot of our customers is it may be that your use case is so special that you need to do that. And I have seen 3 of those in however many years that I've been doing that, right? But this is an abstractable problem. We know that because there are reference architectures for like the SMAC stack going way back in time, Spark, Mesos, Akka, Cassandra, and Kafka. Like these big data tech stacks have existed for some time and are fairly widely deployed. The problem that I have been trying to fight, and that we continue to fight and the hurdle that we try to get over, is that there's a core tension in every single organization I work with, and that is that there is an ever greater number and heterogeneity to the types of data that are being asked to be onboarded into the organization. So they come as streams, they come as batch, FTP is not dead. They come as time series, they come as relational, all of these different types of data that an organization needs to onboard. At the same time, within an organization, or sometimes outside if you have collaborators, there's an ever greater number, an ever greater heterogeneity of people who want to consume, people and machines who want to consume that data. But right now, there's a thing in the middle called the data engineering team, which is fundamentally unscalable. And so what happens? You submit your ticket, you wait a year, you get your data in the wrong format, all you wanted was Fahrenheit, it came to you in Celsius, and still you have to wait for it, right? So we need to start thinking about how do we get around these boundaries. A big part of it for questions like anonymization of data, PII, GDPR, and so on, rely on moving the compute to the data because by statute, you can't move the data, right? So the insights that derive from the data can be gleaned without actually moving the data itself just by running the job remotely. So what we need is something that looks way simpler than this. Like inflammatory thing number 2, I'm going to say, like hill to die on. There is a step function increase in complexity between writing a piece of software for a single machine and writing it for a distributed system. And like, I do not believe that like the wave 2, wave 3, wave 4, the vast majority of organizations, no one here works at one of them, almost certainly, should never be in the business of running their own distributed compute cluster. That should be abstracted away from them. There's just absolutely no reason for it, and frankly, it hurts velocity. So the idea being, we started Mycelial because we were like, well, this is very frustrating. Like, once you get outside the data center, your data story basically becomes do everything yourself, and then we'll get you an API gateway that can eat your bursty traffic. Like, that's not super helpful. So what if we could actually just design a system whereby the data moved based on a set of rules, right? So what we developed was a system that is deployed without any additional infrastructure. So I have, as I mentioned, I was a solutions engineer. I have spent so much time in bank and federal government and hospital and doesn't even in everybody's data center that the installs are so brutal, I just want nothing to do with it. So I was like, if the customer cannot get value out of Mycelial in 30 seconds, it's too hard. And so what we did is we're like, okay, everyone already has data sources in their ecosystem. You're using some kind of database, right? Whether it's like on a mobile device like a DuckDB or a SQLite, or you're running Cassandra or Maria or pick, Percona MySQL, pick your favorite flavor of cloud database. And what's interesting is that another joke I like to tell my clients is like, the one thing I can tell you, there's lots of different databases in the world, lots of different message queues. They all make certain promises to you as a user of those tools about what they're going to do for you. But the one thing they have in common is that every data sync or database in the world, you bring your data to the database and you take your data out of the database, right? The database is not doing that for you. It is expecting you to interact with the database. So all modern databases also support extension ecosystems. So what we said is like, okay, you're already running a piece of software that has a query planner, it has all the things it needs in order to get data, and you're using it today. What if we put an extension, like a Chrome extension, an extension on your database that would observe the changes to the database and then replicate them using the optimal data structure on the other side based on, and that could be many other sides, that could be a staged other side that then rolls into some other stuff. But, there we go. That then rolls into some other stuff. But, we like to joke, if your app is running, Mycelial is running. If your SQLite in your app is running, then Mycelial is running. If your Postgres is running, then Mycelial is running. So we want to move to a state where like there is no ops associated with this above and beyond the ops cost you're already paying. Now, this is all for the purposes, in general, at least in our customer work, of maintaining and servicing growing, expanding AI/ML ambitions for our customers in general, because as David mentioned, that is where the data gets generated. And I want to take a second to just sort of highlight some of the additional costs that oftentimes don't get represented in this world, particularly when it comes to edge AI ML, which is that like today, your data paths look a lot like a Rube Goldberg machine, right? There's like a gumball you put in the top and then it knocks over some dominoes, and then like if the domino falls in a bucket, then the mousetrap thing falls. Like that's generally speaking how we orchestrate these things. And the costs are profound, in particular, in my opinion, around like forget the fact that like all your traffic's no longer TCP over IP when you get out on the edge, right? You have BTLE, you have LoRa, you have all kinds of different communications protocols. If you start working in defense, there's going to be all kinds of new protocols that are coming out soon for privacy reasons. But to me, the thing that really kills me is the fragmentation of teams that are required to roll out incremental features, right? So if you want to have an end-to-end feature in this universe, so if you're I won't use their name, but a big energy company that also owns the largest network of electric car chargers in the United States, if you want to be able to get a temperature reading from an electric car charger over the electric wire protocol and then back into your trading desk where you can make hedging bets based on real-time temperature data, which in the world of energy is relevant, that is a multi-team, multi-step process. Right? You have your edge team. These are generally people writing firmware or very low-level C code for embedded systems. You have your cloud teams. A lot of people in this room I recognize certainly know have held positions responsible for cloud ops. And then you have your AI/ML ops team. And generally speaking, like never the two shall meet. Then on top of that, you have, of course, a general ops team, and then, of course, a security team that you have to get through as well. So some of these things, by adopting a common mechanism for the movement of data, can be abstracted over, and in fact, efficiencies can be improved. So what we like to say, okay, well, what happens when you connect data sources directly? So there's a few interesting elements that are represented on this diagram here. So the first is that if you can represent most of your business logic in SQL, right? And the thing that's so interesting about SQL is that you can find someone who hasn't used a GUI in 20 years, they know SQL, and you can find someone who spends 98% of their day in Excel, they know SQL. So everyone in between also knows SQL. So now we can start to have an organization-wide understanding of business logic described in a declarative pattern called SQL that magically everybody in the organization seems to know, right? And that is an incredible blessing. Because as the embedded database movement of the last couple of years has demonstrated, like, you are not that good at writing your own sort, right? Like, the query planner is always going to beat you. And now that these embedded databases are so fast, like they're faster than fopen, the answer is not why, but the question is not why would you use an embedded database, but why wouldn't you use an embedded database? Right? And so being able to extend that movement by saying, okay, now you have your SQLite, your DuckDB, your libSQL, whatever it is, you're plugging in something to that now gives you access to an organization-wide distribution of your data based on a lot of the same principles that David was talking about. Like, where you are in the Active Directory should define what access to data you get. It should be like an AWS boundary permission or a cloud boundary permission. How many people work at a place where that's even happening today? Nobody, right? So in order to get over the human engineering crunch, this sort of collision course that I described earlier, we need a mechanism that is far more self-service. Step one is give me access to the data. Step two is give me a language to interact with that data and produce new data feeds for my colleagues and collaborate with them based on the ability to just run arbitrary SQL against data that is using a platform like, as I mentioned, we're backing out customers. So that's sort of the first notion, is the one team across the stack. The second thing I want to share with you is just, this is not something I came up with, it's not something we came up with, it's just general principles of local first software. So I mentioned before that it is really something I truly believe that, like, the intellectual burden of going from a single VM world from a single machine world to a distributed computing world is so significant that the abstractions will come before the world migrates to it. This is my opinion. One of the key features of the local first software movement is that all data is local, right? So the source of truth in some ways, or sort of paired truth, is your local data. So the application is always functional even when there's disconnection, which is, we work in mostly adverse compute, what we call adverse compute environments, where disconnection is the norm as opposed to an error state. And so the application will always continue to function. But what's cool about that is that what's cool about Mycelial and sort of the work that we do via extensions is that the data, there's no more APIs in this world, right? As we like to joke, it's like, I don't know if you're Seinfeld fans, but like, why don't you just tell me the name of the movie you want to see, right? So instead of going and reading the poorly documented docs with APIs that like no longer exist anymore and they're funky, you got to pick up a call and then you have to figure out how to sort it. And now you're a database query planner again, and you have to ship it, and the data starts changing and all of that stuff. There's like schema migrations you have to deal with, yada, 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 yada. Why don't you just declare what data should be present, and on change, the system should broadcast that change to the downstream consumers of that of that data source, and have them reconstruct the database on their side, with certain guarantees, such that you have strong eventual consistency. So the guarantees that we make are, if it's this way, if it's ABC on this side, the other side can get messages in order CBA, BAC. Doesn't matter. It's going to come out strongly consistent. It's going to be ABC at the end of the day. And we use certain data structures that might be familiar to folks here to accomplish that. So I promised a use case, and I will dive into it. So this is actually a project that we are working on with David and team at Expanso, in part. And the customer is not named here, but they run a very large fleet of what they call unmanned, but we call uncrewed undersea vessels. And these are disconnected for 99.99999% of their life. They spend months at a time underwater. They go around collecting various types of data via a set of very elegant Rust libraries that some very forward-thinking folks at the Navy have developed, but there's others out there who are working on them if you're interested. In particular, Red Hat has a project called Drogue IoT, run by a fellow by the name of Bob McWhirter, worth looking into if you're sort of into that thing. Also 100% in Rust. So they go around, they collect all this data, and unsurprisingly, they have a few different data stores on the vessel, and Mycelial plugs into the relevant ones, observes change, and notes them. So stores it in either uses the local database. For example, with SQLite, we can do something where it's like a virtual table to store the metadata. Alternatively, we're actually now doing mostly everything, storing it in Arrow, and then that allows us to move it to a million different, to Maria, to Postgres, to SQLite, to wherever we want. We have lots of good demos for that if that's something that's interesting to you. Then, once the vessels pass each other, Mycelial detects that there's another vessel in range and then synchronizes the data between that vessel and itself. And it has a notion through the data cataloging and metadata features of Mycelial that this is data that I generated, and therefore I have to process in a certain way. And this is data that was generated elsewhere that I need to process in a different way. So it's a different track for my data. Now, what's interesting about this, and there's a customer journey in the world of Edge AI ML that I would be very happy to talk about at the next COD Summit if anyone's interested. But what's interesting about this use case is that it's actually sort of a mix of quite a few different sort of data transmission modalities that we observe in our practice, in our company. So lastly, of course, then the data is replicated faithfully back to a place where the relevant personnel have access to it to update models and so on. So I want to point out a couple of kind of neat things, particularly when it comes to Edge AI ML. If you're dealing, disconnected adverse compute environments. So like in particular, if you're working on space projects, like some of these data structures, as far as I'm concerned, are the only way to do these types of things. So one thing I want to point out is that if you look on the sort of third panel of the cartoon, you have two submarines and one edge data center, floating data center. And what's interesting about this is that the submarines, by virtue of the structure of the way the replication is being orchestrated, which is just in Mycelial defined by a set of SQL statements, the submarine itself never actually needs to come to port in order to get its data there. Now you can imagine there's a lot of use cases where you actually want to have a fully connected, forward deployed operating base. That could be something like a vessel at sea. That could be something like a cruise ship. Could be something like an airplane where you want to, I don't know, buy things on the airplane or whatever. And then it needs to seamlessly sync up once one or more members of that data family come into contact with a broader internet, with broader bandwidth. So that's exactly what we have here. So when the edge data center comes into port and they can plug it in, the high fidelity, all the data comes back. That boring driving down the middle of the highway, not valuable for the model data goes back, right? But what's cool about Mycelial is that it's really not enough in most of the use cases where we work, where there is very constrained bandwidth, to have a synchronization scheme that is chronological or in some other way sort of a default, right? Like if I have one tiny little bit of bandwidth, the frame I want to share back from my drone is the one that saw the leak in the pipeline, not the first frame it took when it took off, right? And so how do you know what data is valuable, what data is interesting to the model that you would want to surface or circulate for an active learning scenario, or you know, a new car comes out and you're trying to track cars, you don't know the shape of the car because it's a new model. That's an interesting piece of data. You want to definitely train on that. You want to prioritize the return of that. So with Mycelial, what's kind of cool about it is that through our partnerships with folks like Backyao that are doing the inference, that are doing that compute on the edge, we are then able to take the result of that and put it into a SQL-defined prioritized schema for how you want that data to come back, or to permeate and distribute among your drone swarm or your fleet of connected cars or whatever, right? And by virtue of that SQL definition, again, the reverse happens in Piggyback. You can have one truck that leaves the warehouse and goes to a forward operating base. If that truck has data that people in the forward operating base are subscribers to, they will receive it, okay? Once it joins the local network there, and of course it operates over local network too. So that's a description, a pretty valid one in terms of its representation of the nature of our portfolio business. So I do want to just take a moment to list a couple of pieces of technology that if you're here thinking about starting a company or you're thinking about a direction to take your project, these to me are the ones that I'm most excited about, and that VCs, if that's your bag, also seem to have strong investment theses around. In particular, like embedded databases, like if you saw the amount of money that Martin Casado at A16Z just plowed into DuckDB, I mean, that's crazy. Like it's going to be the next big thing. WebAssembly, also, I mean, I'm not going to bore you all with the details of WebAssembly, but there is definitely a lot of money out there looking for WebAssembly bets. Though you don't overstate it, because folks recognize that the ecosystem is a little bit in flux. SQL, anything defined, like being able to say that you now have declarative data in this resonates with people in the same way that like when people said you could have declarative orchestration, right? People understand that now in a way that they didn't before. And I have to say, like, it's kind of crappy, but like a lot of the data leaks are also leading people to look for more declarative solutions to their data, because implementations can oftentimes be the source of data leaks. And lastly is conflict-free replicated data types. So the first thing I want to say is that in Edge AI/ML, conflict-free replicated data types are not necessary 98% of the time. Where they are necessary and or convenient, at least in the use cases that we've seen today in the market, I'm not projecting forward, is among coordination of autonomous assets in the field. So if you have disconnected stuff and even connected stuff, like if you're using like a counter CRDT for rate limiting on load balancers or something like that, in the data center it has use cases as well. But in particular for coordination among autonomous assets that need to operate together in some kind of unified piece of state. So digital twins oftentimes look like good bets for CRDTs. As do, of course, the traditional use cases like collaborative text editing. Doesn't come up that much in Edge AI/ML, or collaboration sort of in general. But it's the thing that's actually most relevant about CRDTs from an Edge AI/ML perspective is not any of those cool features. It's the fact that the system will always roll forward, right? The fact that you will never get bogged down with a conflict. So next inflammatory statement. If there's no cloud native engineer on an asset, there should be no cloud native software on that asset. Because I don't know how many people have ever seen a Kafka cluster run forever without maintenance, but like I haven't. We need to move to a world, particularly for these use cases, where we're talking about single binaries like Backyao, or like us, we're an extension to the application you already have. Like this is the level of complexity. Like if System D can't run your platform, it's a little too complex for anywhere where there's no cloud native engineers. So save yourself the headache and look for alternative architectures, because it's early, but they exist. And I'm more than happy to talk to you about it. And with that, I have 1:30 for questions. Thanks everyone for coming. Holler at me. This guy's gonna have like 1 million steps now.
Simple question. So how does it actually ship? If I have a Postgres, is it a Postgres extension? Like, what's the form of my... So you guys kind of busy writing extensions for all of the databases? Like,
Great
yeah,
question.
that's
Yes. In short answer, yes, there are some shortcuts depending on the nature of the database. Like relational databases, it's easier to play with relational databases. Certain other data stores, like Kafka, likes to speak in terms of messages. So we take the burden out of delivering your relational data or whatever time series data into that kind of a format. So yes, the goal is, like, I kind of want to steal Benioff's no software. You remember that from back in the day at Salesforce? Yeah. Of course, it was software. I mean, we can have a drink and talk about the Salesforce platform later. Anyone else? R.I.P. Heroku. I don't know. Anything else? All right. Well.